Hello everyone, this is Mehak and today we are going to discuss about novel electrochemical cells used for operando techniques and impedance studies. While we know portable power sources have experienced a rapid evolution for the past decade that has led to discovery of more efficient devices for various applications such as mobile phones, GPS navigation systems and laptops. Lithium ion batteries are the best system to deliver high power and high energy. The best way to study a reaction mechanism occurring during charge-discharge cycling of batteries is to follow it on live. Such a measurement is called operando or in situ measurement. In the cases of these measurements, we can avoid the following problems, that is, degradation due to air exposure and unwanted crystal structure changes, etc. Now we will proceed towards novel electrochemical cells. What exactly are novel electrochemical cells? A novel electrochemical cell has been designed for operando experiments at synchrotron facilities and in-house. The cell can be adapted to the most common techniques such as X-ray diffraction, X-ray absorption spectroscopy, neutron diffraction as well as electrochemical impedance spectroscopy, etc. On moving towards a coffee bag electrochemical cell, we see a coffee bag electrochemical cell consists of several flat parts assembled in order to have a thickness of 1 mm maximum. The goal is to minimize the presence of different elements inside the batteries such as current collector and to maximize the presence of electroactive element in the beam. Due to high reactivity of the lithium with air and moisture, coffee bag cell must be air and moisture tight. For this reason, the cell is sealed in an aluminium bag 100 mm thick where the foil is composed by 4 layers from the inside to the outside. They are polyethylene, aluminium, PE and oriented polyamide. The PE layer is thermosealed while the OPA layer is not, thus being on the outside of the cell. The only problem of such composite foil is that this introduces additional peaks in the XRD pattern. In order to avoid this problem, a hole was done in coffee bag cell and the aluminium was replaced by some krypton type to avoid any Bragg's reflection from the window. This graph 3 shows the charge-discharge curve between the second and 36th cycle of a coffee bag cell with pressure. The polarization is almost same in the second and 36th cycle. On seeing the comparison of charge-discharge curve between the coffee bag cell and the standard coin-type cell LiFePO4, it is seen that at a relatively fast rate, such as C/4, there is clearly no visible difference between the coffee bag cell and the standard coin-type cell. You can clearly see that there is a biphasic plateau located exactly between 3.4 volt and 3.55 volt. On a closer look, the difference between the polarization of two cells can be seen. There is an increase in polarization of coffee bag cell compared to the standard cell, maybe due to the degradation of the active material. Due to lack of good and reliable cell with pressure dedicated to operando studies, we decided to modify the standard coffee bag cell to improve the pressure coming from spring in order to obtain the similar result than those obtained by coin cell measurements. This is the image showing modified design of a coffee bag cell. Now we will see some facts about polypropylene layer. A double polypropylene layer was also added in four edges of the coffee bag cell. It plays various roles such as it creates a better sealing interface between the titanium and aluminium foil. It also helps in avoiding short circuits in case there is too strong heating occurrence chances. It also helps in preventing air exposure and moisture. Next we will see about the titanium as a hard window. Its main goal is that its mechanical strength is high enough to support high pressure coming from the spring. Here graph 4 shows operando synchrotron XRD pattern when no pressure is applied. On the other hand, graph 5 shows the representation of operando synchrotron XRD pattern when pressure is applied. This instability is one of the typical disadvantage of a coffee bag cell without pressure. So in this research paper, the researchers have demonstrated a new way to apply the pressure on a coffee bag cell in order to obtain a very reliable system. By using TI hard window and aluminium, we are able to avoid air and moisture exposure, increase the lifetime of a coffee bag cell. Figure 4 depicts the modified coffee bag cell design including reference electrode for the impedance spectroscopic measurements. Thank you.